So without further ado, I will introduce Peter Eisenberger, who is a well-known and prominent figure in climate science, has been for many years. I don't think he really needs an introduction, although I will do my best here. He is currently a professor at Columbia University and the co-founder and CTO of Global Thermostat, and also a co-founder of the Elk Coast Institute, and I'm sure involved in many other projects as well. And in his emphasis has been on carbon removal, and particularly, technologies for doing that at scale and rapidly, and with a view toward equity, toward general energy equity that I know Peter believes is absolutely critical to having a speedy and rapid transition to a sustainable future, which he has called in another paper, the renewable energy materials economy would be a future where we could close the carbon cycle and sort of take over part of what plants are doing right now. And that does have the potential to be a more, not only more sustainable, but also more equitable future for human civilization, because that would, you could source the energy and the materials potentially from all over the planet, from the oceans, from the air, much more broadly from the sun and from the wind, than with the system that we have right now. So I will let Peter explain all these ideas and what he's been doing. I mean, he's an active entrepreneur as well as an academic. So, Peter.
Thank you, Ron. So before I go through the slides, I'm going to tell you a little bit about what the talk's going to be about, and about some aspects of it. So I'm going to share with you my view of the two challenges we face in the 21st century: increasing equity and addressing the climate change threat. I'm going to provide you with some conceptual framework and provide a more detailed example for direct air capture, but the concepts apply to all climate-related efforts. The new not-for-profit Equitable Climate Innovations has as its mission to enable the developing world to disproportionately benefit from the transition to a new, as Ron said, renewable and energy economy. I'm still associated with Global Thermostat. I'm not the CTO. I've stepped down from that, and basically don't have much line responsibility, but will continue to invent and continue to be on the board of the company. But my main focus with Nadia is going to be on this new not-for-profit that we've established, which has the mission I just described to you. So with that sort of framework, let me go on to the framework of the talk, right? So let me just get rid of this thing here. So as is indicated here, and I think most of you, but from hearing your introductions, recognize it, it's not one challenge we face in the 21st century, that is the climate threat, but it's two. It's the need for equity. And so most in the beginning, and certainly for a long time, and even now, many people just come up with solutions to addressing the climate change threat without considering its impact on others than the developed world, because most of the ideas at the moment are coming from that direction. And so that's always bothered me. And both Nadia and I held this workshop that confirmed that really the two are very related in ways I'll describe. Next slide, please. The framework for this whole talk at some level is captured in this slide. Namely, if you look here, what's plotted is the UN index of development, food, shelter, basic needs, basically, versus on the x-axis, the amount of energy available per capita to people in various countries. And you can see that there's an amazing disparity, right? All the ones in the developed world on the top and all the developing countries on the bottom. I mean, the ratio between those citizens in those countries for the energy available is, an unbelievably small fraction of what is the developing world. And therefore, I've defined on the top what I think is the goal of the 21st century, and that is to provide every human being on the planet with the energy they need to develop to their full potential. So that's the long-term goal, and I'm going to describe to you in the talk how one can start to approach that goal by making sure that the innovations we create don't repeat the past industrial transformations by increasing inequity, but rather reduce it, and have to reduce both the inequity and the climate threat at a very fast pace to avoid the consequences. If you go to the next slide. Next slide, yeah. So here I describe the two consequences. Lack of equity is going to create social instability. It's unavoidable if this disparity continues, and you can see it's beginning to create that instability already in various countries, if not our own, in the United States, because all the knowledge is much more prevalent about the gross inequity that exists, and the people that are suffering from that inequity have lost patience with it and need it to be addressed now. And of course, the climate change threat threatens the planet itself. And the two, both social instability and climate change devastation, are intimately connected, as the recently pandemic demonstrated very clearly. So, furthermore, it's been clear to me for quite some time, having attended some of the earlier IPCC meetings, that the big problem from preventing us from reaching a global accord to address the climate threat is the different views of the North and the South. And basically, they boil down to that the South is correctly asking for equity in that solution, until very recently, the North seems to have been reluctant to do so. But you can see in the most recently finished Egyptian COP that is front and center. It actually was in the previous one. So, and you can see it in DOE grants, in justice, that's beginning to emerge as a criteria for all our climate-related efforts. And that's a good thing. And I think it has to continue to increase. Now, so in both cases, as is obvious, they present an unprecedented challenge, something the human race has never addressed before in terms of its scale and complexity, and the time that's available to address it. And so we need to do some really unprecedented global mobilization to address that in time. Not only are we technologically challenged, but most importantly, all our policies have been sort of adjusted to the fact that the primary source of energy has been fossil fuels, and the primary system has been one that has resulted in the lack of equity. So equally important to the new technology that's needed and available. I believe we have all in our toolkit, all the technologies as represented here and many other places that we need to address the climate threat and also the threat of inequity. But it's a matter of choosing the right ones and doing it the right way. In any case, that's heavily influenced by government policies and financial systems. And they need innovation as well, as much as climate does, as the technologies do. And it's a very important focus that I know is, again, beginning to get increased attention, and was featured in the last workshop that Nadia and I held on equity and energy. The next slide, please. So the question that I want to delve down to a little bit, because there's a lot of confusion about it, and I'm going to do it at a somewhat quantitative level, but I'm not going to expect you to understand the at a quantitative level, but get to the main gist of it. And so everybody's talking about net zero, but any reasonable analysis of the amount of carbon that we need to remove from the atmosphere means that net zero is not enough. Like even the most optimistic plans, as I'll talk about, of renewing and doing all the other things are not going to be sufficient, mainly because it's become very clear, mostly by the recent events in Europe, that fossil fuels have to be used for quite some time, because if they weren't used, it would create economic devastation and further exacerbate inequity. And so we're going to be using fossil fuels, and any plans we have not to do so are not viable. They're not politically viable, nor, in my opinion, are they morally viable. And so, from my point of view, the fossil fuel industry has really enabled us to be on this Zoom call today, and has provided us all with great comfort and great advances in our standard of living. So they're not the evil organizations. They've just been doing some very positive things in an era where they were needed. And of course, they're going to be changing and are changing, as evidenced by their recent action to adapt to the new reality. And they'll be just as essential in the new reality as in the past. And one of the things we don't have is time to build new Exxons and Saudi Aramco's and other oil companies to address the climate threat and the challenges we meet the challenges we face in the time needed and the scale needed, and without also causing great inequity and social instability, which makes those solutions not viable. So with that larger picture, let's go to the next slide, please. So here's a simplistic view of the carbon cycle, and I only want to make a couple points here. And though a lot of those points may not be broadly appreciated, but maybe it is here among most of you. But it's something I say in my first lecture at Columbia about this subject. If you look to the left, you'll see that the nature is exchanging between the sea and the ocean about almost close to 100 gigatons of carbon each year, back and forth. And that's an exquisite balance, except for a small amount. And that small amount changes with time, dependent upon the sun relation to the planet, and alternates between going from a colder climate to a warmer climate. And we've gone in the history of the planet from a polar frozen Earth where the 80% of the planet was covered with ice, to an era of 1,600 parts per million carbon where we had palm trees on the poles. And so nature has adapted. Of course, it moves slowly. So it's not, it's really the rapid rate at which the 5.5, that's an old number, gigatons of net emissions of carbon that the humans are doing, but it's just enough to be significant. Matter of fact, it's twice as much as the amount that's not currently being sequestered in the natural systems. I try to point out to us how lucky we are. If the planet had been in its other cycle where it was emitting a net amount of about 3 gigatons of carbon a year, then the climate threat would be 3 times as much as it is now, and would be advancing 3 times as fast. So if you go to the next slide, this is just a example, and actually it's a slide I got from Klaus Lackner when he lectured in my class, and it may be familiar to some of you. But basically, it does capture very nicely the issue, and that is that we're now at a point in 2020 where we're awfully close to the hazardous level identified in the Paris Accord of 450 parts per million, which is associated really with the 1.5 degree solution. And have 3 at that time, where 3 scenarios continued our growth, which is going to be obviously devastating. Constant emissions, right, which is shown there, and then of course there are various solutions trying to get to just the hazardous level, or as Peter Fikowski has done, and I have some issues with, which we won't talk about here, trying to get us back to the very cold pre-industrial state. I, for one, in California, really like a warm climate. And so one of the things I tell my students, the real problem we're going to have to face is who controls the thermostat to decide what the average temperature of the planet's going to be when we remove the planet CO2 and get it stabilized. Next slide, please. Oh, go back to that. No, I'm sorry. Thank you. The previous one, please. That one. So here is, I think, roughly, disregard the magnitude. I think here, even in the most ambitious solution approach at this time, all things going positively, is the reality we face. We're going to go past the 450 parts per million. And however, we can come down very quickly if we build the necessary capacity. And since there's a certain amount of inertia in the climate's response to the CO2 in the atmosphere, if we can make that fast enough, we probably can help avoid some of the more disastrous or catastrophic impacts of climate change. Of course, the reality exists that our predictions could be wrong, and the 450 parts per million is above the catastrophic level, and there's some indications that may be the case in what's currently happening, because everything seems to be changing quicker than we thought in spite of our efforts. If we go to the next slide, people have attempted to model this by modeling future economies and the emissions they see. I've always been somewhat skeptical of this, but I think conceptually it's very illustrative. You could characterize the ones that have on the top that have increased emissions as the pessimistic ones, and the ones on the bottom that are the optimistic ones, right? And so, and then you have on the right, you have the other emissions of greenhouse gases. So in the analysis I'm going to share with you that I did with Matthew Ralph from Georgia Tech, we're going to assume something in the middle, right? We're going to take a flat line. Now, if I could have the next slide, please. So here is our stylized emissions profile, right? We're going to keep it constant, right? And we're going to have a ramp down, a simple slope ramp down to emissions of 10 gigatons per year, and then a level off. So I want to make one point here is that net zero, right, really is net zero. It doesn't mean zero emissions. It means that you have to have an equal amount of carbon removal to make it net zero. But as the previous slide showed, net zero is not enough. You have to have carbon negative in order to successfully address the climate change threat. That is, you have to not only match your emissions and remove that amount of carbon, but you have to remove 2 to 3 times as much from the air in order to avoid catastrophic climate change. Next slide, please. So now, every technology, and this is, as I said, I'm going to use DAC as an example, but to apply the concepts apply to other approaches. Every concept has to be worried about its cost and its scale. Can it be a meaningful scale to address the climate change threat? Well, I think it's widely acknowledged that DAC has the scale possibility, right? But its cost has been questioned. And this is one of the errors that many people make about determining costs. And it really is unfortunate because it's holding back a lot of the innovations that are needed to address the climate change threat in the time available. Namely, they talk about today's costs. But every technology throughout human history has always started out high, and inevitably, through the process of learning by doing, has had their costs down. With the simple basis of the logic behind learning by doing is that human effort with their brains and knowledge will continue to improve things. And so the more people you have, or the more effort you make, the x-axis is effort, or as implied, installed capacity, the more you learn and the lower the costs come. And there's a lot of formal analysis, learning curve analysis, and this is showing some examples of, for DAC, which depend upon the various ones depend on different learning rates. The higher the learning rate, right, the faster you come down. Okay, so the and of course it depends upon what the cost is at the starting point, right? So I've used a conservative. You can use a conservative thing of $500 because what's amazing about direct air capture as opposed to solar is it doesn't have to learn by doing as solar has done by 3 orders of magnitude reduce costs. That's the amount of has been reduced from the first use of solar in space, but it only has to go by a factor of 10, just a factor of 10. That's an amazing low level, and from the point of view of global thermostat, we're more even lower than $400 per ton in our plant we're currently building. So, but that's a detail, and it's not important. So when you take all that and you have some idea of what you're going to need, and it's tens of gigatons. The estimates vary from 10 to 40 gigatons. I believe 40 gigatons is more likely the case of capacity we need to develop. But here, I'm just showing you what is needed to develop 1 gigaton of capacity by 2060. 1. And you see the required growth rates are very high, and they get even more steeper. Those great growth rates are beyond most recent innovations. They're certainly beyond solar, or solar now has a 25% growth rate, right? And its growth rate should also benefit from a little mobilization, but it doesn't need it as much because it's already on its learning curve. That has to get on its learning curve, but it has less learning to do. But in any case, the whole point of this slide is to show that without an unprecedented, even the mobilization we did in World War II to build ships for a brief period of time came close. And when we commandeered Ford to build tanks and Exxon to build rubber, we were able to meet the thing, and Roosevelt increased the budget of the US by a factor of 9 in 1 year. in 1 year. And you had war bonds and people gave all their savings in order to address the threat. It's that sort of effort that I believe is needed. And if we do it, not only will we be successful, but it's going to bring us together as a species. So that's why time is so important, which is the main concept I want to get across. We don't really have much time to research. I've done innovation and research development. I can almost guarantee that any idea that's not yet been piloted is not going to be developed in time to play a major role. I know that may be hard to accept, and I could, of course, be wrong, but based on, certainly, I might exempt things like cloud brightening and other stuff like that, which have other problems, but where the technology implementation is fairly straightforward. But doing it in a way that doesn't cause adverse consequences is not straightforward. And as I've written many times in the blog, it's going to take as much time to get the political consensus to do that as it would be to develop alternative approaches. But that doesn't mean one shouldn't continue to do it. I'm all in favor of increasing our knowledge. So anyway, if you go to the next slide. So I want to now turn to saying, how can this need to scale a technology like DAC and other climate technologies in a fast time? As I said before, one can't do it without at the same time having to do equity, increase equity. In the past, our equity has been moral, philanthropy, obviously low priority, low expenditures, and viewed as a cost to the economy. Well, that sort of approach to equity has got us to where we are. In the future, our equities have to be moral, and important, and they have to be as clearly strategic and commercial. They have to have a higher priority as other efforts, high expenditures, and will result in increases in economic growth, which I'll talk about now. So if you can go to the next slide. By the way, I should have said, I'm sorry for not saying that, if you want to interrupt me at any point to ask a question for clarification, please feel free to speak. In any case, in addition to changing our attitude about equity, we have to have a different paradigm for managing the carbon cycle than we've had. So this is the example of our past efforts. And that basically involved emission reduction, avoided carbon, and storage. And the Clean Coal Initiative was an oxymoron, if I ever heard of it, but it still was a government policy for quite some time. And then it was been replaced by, we're going to switch to natural gas and do other things and grow renewable. But the full conversion to the next slide has not occurred yet. All right. Next slide, please. So the new approach is what I call the renewable energy and materials economy, as Ron described. Well, it was going to take atmospheric CO2. This is the carbon cycle part of it. Atmospheric CO2, and you do two things with it, right? Use it for materials that can store it, and provide energy that is carbon neutral. And the reason that CO2 is so centric is obviously because CO2 is the core of life. If you go to the next slide. This is captured here in the renewable energy and material economy, where on the bottom it says that this economy mimics nature. As Ron says, it replaces industrial processes with exactly the same functions that nature does. And I have always believed that we can outperform nature, as demonstrated by our dominance that we've achieved, which has also created the problems we are facing. But still, the power of our brain together with knowledge is an amazing phenomenon that I find hard to understand how it's possible that since we all have emerged here from pure energy. It's mind-boggling to say the least. But in any case, here's what are the components of REME. It has only 3 inputs like nature does: atmospheric CO2, renewable energy, and hydrogen from water. And in the next column are listed the technologies that currently are available to provide the renewable energy needed to power this economy. And on the right, the next column are the industries that will have their products be able to be produced by the combination of carbon and hydrogen, and which is an amazing percentage of our economy, not surprisingly so. And you can see all the products on the right, and there are many more that will happen, right? And so, but it's just I can see there's nothing. For example, like carbonated drinks, right? People are drinking carbonated drinks from CO2 that was taken from a chemical plant. And once they find it out, they're only going to want to have CO2 that's provided from the air, pure air. I often think of like Rocky Mountain water for Coors beer. There's going to be somebody's going to come out and said air from the polar north that's CO2 to use to make carbonated drinks. In any case, next slide, please. Well, if I make one thing is that I do believe having the new technologies penetrate to the individual life, like in sodas, is very important for the social transformation that's needed to be provided, need to accompany this, and it has accompanied other industrial revolutions. Next slide, please. So here is just a statement that it's clearly a sustainable solution because the inputs to it are just renewable energy, the air, and water. That's the new inputs to production in the new economy. And the energy, those inputs are distributed more equitably around the planet than fossil fuels. And that's what's going to be a major asset in having a more equitable outcome. And next slide, please. So this is my last slide, and it just gets a little more granular about the processes and the specific materials that are going to be produced. So I hope in this short presentation that I've been able to convey to you some of the concepts that I believe are critical for our species to address the threat of climate change. Of course, I'm a scientist and recognize it can be wrong, and therefore I really am making a lot of attempt to currently with Nadia to expose these ideas to others and hear their critical comments or their suggestions of how to improve it. And that's why I'm very happy to be here today and listen to you about your comments. Ron, turn it over to you.
Great, thank you. Thank you very much, Peter. So let's go to some questions here. If people want to raise their hands, or in the reaction, where's the reactions? Just raise your hand, and I can see you. Okay, it looks like I'll try and keep the queue straight here. So, Mike.
Hi, Peter. I guess let me say I have a neighbor who's an Ethiopian businessman, and they want to scale up their energy. And the idea of doing it with fossil fuels, because they don't have any of them, would be very draining of their finances. So I'm very curious about your proposal about continuing fossil fuel use.
Right.
Are you referring that to countries that already have it, but countries that don't, you would build up with renewables, or what?
Yes, Mike, that's a very good question. So listen, I, for one, have developed technology like carbon negative power plants that burn natural gas by simultaneously removing the CO2 from the flue and using their low temperature heat to take CO2 from the air. So those carbon negative natural gas power plants are actually better to address the climate threat than solar, because solar is neutral. It just provided energy that has no carbon emissions. But using natural gas in this way, as it provides the same electricity, but that electricity is not carbon neutral, it's carbon negative. So one can remove about twice as much carbon in our technology from a natural gas power plant by both using our flue gas technology and our air capture technology in the same plant. And I think that's going to be a very important approach to using natural gas. And by the way, I agree with you that the focus is definitely in the developing countries. Right? I'm not, as I said, my new foundation is going to focus on implementing that sort of thing and the green economy in the developing world. I'm not putting no effort to do it in the developed world, right? And so, and that's where, if anybody thinks about it, 90% of the economic growth is going to happen in the 21st century.
I mean, but for Ethiopia, countries like that, they basically have solar and hydro, and they don't have any fossil fuels. And there's a lot of countries that they don't even have natural gas. So those countries should, I mean, if we're going to help them, we should be helping them with renewables, so we don't have to make two transitions. Right?
Oh, without a doubt, Mike. Clearly, I said I'm sure it was
okay.
I didn't give it enough emphasis, but I definitely said both solar, all renewables, nuclear important, most importantly, have to be scaled at the mobilization pace in order to do exactly what you want. What you're saying is to make sure that those countries that are not now dependent on fossil fuels, right, and don't have or actually being hurted by it, right, in terms of they don't have it on their own energy, they don't have energy security. They're depending on others for their energy. Those people should definitely be the focus of scaling up renewables, right, and no effort to bring natural gas to them, right? Because the key word is, just let me share briefly a story. I worked on solar about 20 years ago, I got about 30 or 40 years ago, actually, with Exxon, when we thought we were going to run out of fossil fuel. And one of my roles was to see how it could be used. And I went to India and I talked to Indians about adopting the Exxon solar technology at the time. And they said, only if you give us the capacity to build it ourselves, right? We're no longer going to buy technology from the West and be dependent upon them for the expertise to innovate on it and run it. So a very important requirement is whatever is done, the equity part, the capacity building part needs to accompany it. So in summary, definitely there has to be a very clear strategic selection of what projects to do where, and have the economic incentives, the policy, the financial instruments support and encourage that be followed.
Yeah. So when I had just briefly one more, when I had my interaction with Rex Tillerson 6 years ago when he was head of ExxonMobil, and they were projecting growth from 90-some million barrels of oil a day to 130 or 40. Virtually all of that increase was to go for transportation energy for the up and coming younger generations in Africa and Southern Asia. or something like that. I mean, it seems to me what we got to do is make sure that isn't the way they go, that there are other ways to power transportation and stuff. And so we really need to provide them electricity to do it or something.
So Mike, I couldn't agree with you more. And as you know, I worked for Exxon 30, maybe I remember. I worked for Exxon 30, let's see, in the 1980s, late 1980s. And so at that time, as I said, I did solar. I've now reconnected with them, in particular with Vijay Swar, the head of their research and development. And we have worked together to the point that Exxon has now declared, as has Saudi Aramco we work with, that they are going to want to feature and lead in the implementation of DAC, of direct air capture. And they have recognized and changed their outlook for the amount of oil that will be consumed. And I think it's pretty consistent with it staying constant. But that depends upon various things that as I said. So one of my efforts has been to work with the companies that have the capacity to address the threat of climate change and convince them to make the switch now. I'll give you another example. I've been working with Corning, and their monoliths are critical to our technology. Well, they're suffering a loss of business in their catalytic converter because of electric cars. So they have enormous spare capacity, and they therefore have, like Exxon has done, and Exxon has established their low carbon solutions as a third branch of their organization recently, and Corning has now established a new business in carbon removal. So companies are going to see that the economy is changing inevitably, and they're going to make significant changes in how they conduct their business. Next, who's next?
Yeah, so I think Brian.
Yes, thank you. I've got a couple of related questions and a comment. The questions are relating to this carbon negative fossil technology. I think it would benefit this group to have a bit of quantification on that. First of all, relating to the efficiency of flue gas carbon capture in terms of the percentage of carbon actually captured and the percent that still goes up the stack. And then secondly, given the amount of energy production and the amount of carbon being emitted, that produces some amount of waste heat, but is there any presumption or do you have any indication that in fact the direct air capture can even come close, given the amount of entropy involved to actually capture all the CO2 molecules and then sequester them? And finally, I'll note with interest that we're already above 450 parts per million when you include the 60 odd parts per million CO2 equivalent of methane and its superlinear increase that we've seen in the past decade. Thank you, Peter.
So listen, Brian, the notion that energy is a problem with direct air capture has been refuted a long time ago, because the first step in carbon capture is exothermic. Energy is released, and usually when you have to separate low things, there's some energy needed, like driving the molecules through a membrane that is impacted by the dilution that you have to require. So there's a very minor difference in energy needed to capture CO2 from the air and CO2 from flue gas. And energy is not going to be the core, the limiting thing. It's going to be capital. So now, to answer your second question, clearly we do a carbon accounting, a full life cycle analysis for our carbon capture, carbon negative power plants. And yes, it's about 90% efficiency of the flue. So we take the 10 that goes in and we subtract it from the rest. As now, this is assuming that's it. Because the rest, as you point out, with the heat energy requirements that can be achieved, not maybe today, but as I pointed out, learning by doing, that's going to be one of the major things that one does with learning by doing, is increasing the energy efficiency of a technology, right? So
Yeah, so if you or Nadia could post the life cycle analysis for the carbon negative power plant, that would really help this group, I think.
sure, I don't have it available here now, but I'll be glad to send it to you. Right.
Yeah,
Okay.
and then if you could comment on the methane part of it, I think that's worth noting about your 450 line, because we're already above that.
You raise a good point. I don't know whether the scientists in making the 450 parts per million for CO2 included the other greenhouse gases or not. If they didn't, you've identified.
No, they didn't increase it. And I think there's a giant fallacy going on at the IPCC, and that is, oh, the methane's going to boil off to, convert over to CO2. Don't worry about it. Well, that's fine when you have a decreasing pulse, like an impulse of methane that then decreases. But as we've seen in recent disruptions, we have a superlinearly increasing level of methane with an instantaneous greenhouse gas ratio, maybe 120 to 1 by volume.
Right,
Now
right,
by mass,
That's
by mass, so the multiplier is a lot higher. And when you balance it all out, we've got to account for the methane in the atmosphere already, which is quadruple what it was pre-industrially. And yes, by that accounting, we're at least at 480.
Exactly. And I'm saying, I couldn't agree with you more, Brian. In the overview, and I said it before, I believe 40 gigatons of removal capacity is needed, not what most people are talking about with net zero of 1 to 10. That's ridiculous, right? And for all the reasons you're saying, it really has to be high. My assessment is something like 40 to 60 gigatons. But the interesting thing is that once you, like in the semiconductor business, once you develop the capacity, right? Let's say you get to that's why we featured the gigaton capacity. Then it's not that difficult, as semiconductors did, to double it every year, right? And so then you get 2 gigatons, and then 4 gigatons, and then 8 gigatons, and 16. So in a very brief period of time, and that's what the overshoot was made. At that last period, you can think about how fast do I have to do how high a capacity do I have to get to bring that overshoot down quickly.
That's a really good point. And on your one small point on your Wright's law curve is if you plot it on the log scale, you then get a straight line. I think that makes an even more compelling case. So just a small suggestion. Thank you, Peter.
Right. Okay, Ron.
Yep. Thank you, Brian. I think next is Robert. Chris.
Hi. Yeah, that's just a really fascinating talk. Really hit all my hot buttons here. One of the things that has really impressed me about climate change, right from my first involvement with it more than 20 years ago, is that we have never been short of solutions to the problem of climate change. The technology has always been there.
Right.
Back in the 1980s, it was there.
Right.
But our consistent failure to implement those solutions on a timely basis has meant that the problem has increased exponentially. And of course, the solutions that we now have to consider themselves have had to grow considerably faster as well.
Exactly.
So the problem that I'm confronted with here is not about the technology. I don't have any issues about the technology. I'm not a scientist. I'm not an engineer. I'm constantly in awe at the amazing things that our engineers have done over the centuries.
Right.
The problem for me is the politics here.
Right.
The politics and the social movements.
Right.
Because what is underpinning what you're saying, Peter, is a huge amount of change, both at the everyday level for people's lives across the world in different ways, in different places, but significant change. But most particularly, it entails a very dramatic change for the global political and economic elites.
Right.
Because what is contemplated here is a significant change to their power structures. And we are confronted and have been consistently by an extraordinary successful move on their part to resist those changes and resist any activity which might undermine their supremacy. And my question to you is, I love what you're saying, but how do we get an orderly transition from here to there? Don't talk about the science, talk about the politics. How do we make an orderly transition from here to there?
Okay. Very good question, Robert. And I tell my class the following at the end. I say to them almost exactly what you say. I said, I can't say that we're not going to have a disaster, right? But what I can say, that depends upon how much climate devastation has to occur before the planet wakes up. So we're now seeing, as the forest fires and the floods start to ravage many countries, the political consensus, certainly among my grandchildren, is clear, right? Climate is number one. And that was somewhat reflected in the recent election in the United States, where they voted with unprecedented numbers. And so my answer to you is, I can't guarantee it. I agree with you. It's a political will. And I know what's going to drive the political will, because as you said, nobody gives up their supremacy without a fight, right? It's in human nature to do that. It's part of the whole system that helped get us here. But we have to change from competition to cooperation. And that is something that is foreign, but will be driven as it was in World War II. And it was in this pandemic, right? That companies that you normally were competitors had to cooperate to address the threat. So the threat is the forcing function to the political will. And it will be forced on them because it's the individual people that are going to be affected by these climate change events. And they'll elect leaders, or they'll storm their houses to get it, right? If it gets very serious. And, this is all validated by the American Defense Department having identified this potential for creating social instability by all these climate disasters as a major threat to humanity and to the U.S. So, and you can see it. I mean, I've been in this effort for almost. We filed our first patents in 2005 and wrote our first paper on carbon negative things in 2009. And so since that time, it's been a struggle with the deniers and all that. In the last year, the pace of change in the US and globally is amazing. We skipped from the DOE not providing funds more than tens to $100 to $1 million or so for air capture or those sort of things. They were all focused on clean coal, to now having $3.5 billion allocated for DAC, for direct air capture, with a moonshot for vision that would get a lot of funding to do a demonstration of a path to a gigaton plant. So we're moving in the right direction, right? There's emerging political consensus, but the question still remains, will it happen time to prevent catastrophic disaster? And you're also right, Robert, we've delayed so long. When I first did it in 2010, did the analysis, and I have this and other things out of my lecture, the amount of carbon we had to remove was, as you pointed out, was very little. Easily done, right? But now we've delayed so long, it's going to take a Herculean, unprecedented effort to address it. Okay, Ron?
Aria?
Hi.
Hi.
Peter, great to see you again.
That's you.
Yeah. So, I know we broached upon this in the past. I have a lot of concerns about being able to use the framing of equity behind continuing fossil fuels. I mean, 9 million people die every single year, irregardless of climate, just because of health impacts. And that doesn't even take into account the environmental devastation in our water supplies, the destruction of the Gulf of Mexico, and, you know, in various other cover-ups that I've been privy to in regards to oil spills, et cetera.
Sure.
And at this point in time, renewables are actually cheaper. Hold on a second. You know, we're subsidizing it to the tune of trillions of dollars every single year around the world, and the damage is offset to people who cannot afford the health impacts or, you know, the other impacts in their areas.
Right.
So, you know, I know that renewables aren't perfect in terms of environment as well. But I do have a certain amount of hope. You had mentioned something about the transition of, you know, the cost of transitioning to renewables. And my understanding, and you may have some more data around this, is that natural gas, you know, energy plants can be converted to hydrogen fairly easily, according to people that I know who work in hydrogen, the way that they have framed it to me. I also have some very recent concerns around hydrogen that are very new in terms of them potentially having some indirect warming potential, but apparently that only has to do with leakage. And so if we could take that hydrogen, preferably green hydrogen made from water and, you know, other sources like that, and be directly creating electricity without having to store large amounts of hydrogen, it would seem to me that that could be a direction to go to help replace, you know, some very damaging natural gas plants, which are having, you know, in terms of methane leaks and impacts on our water supplies are quite considerable. I'm wondering what your thought process is around hydrogen, for instance, and that being a viable way to help make this transition in a way that could be greener and more equitable with less environmental damage, while also dealing with climate.
Okay. Well, thank you for that question. Let me first clear up one thing. I certainly forgot to say in this talk, but it's a constant of my thought, that obviously before you use natural gas power plants, you've got to address all the environmental leakage issues, all the issues that you've raised, okay? They have to be addressed, okay? But I just want to make that, I'm not ignoring those. You're 100% right. We cannot use them the way they're currently being used. There has to be a lot of effort put in to make sure the leak button and so forth. However, on a more general level, here's my thinking. And it applies, I must say, to electric vehicles as well. Electric vehicles and hydrogen do not have an existing infrastructure to globally implement them. The cost of establishing that new infrastructure is enormous. And for me personally, I would rather have it go to education, to improve education globally, rather than develop a new infrastructure at this time. And in fact, because the synthetic fuels, like gasoline made from CO2 from the air and hydrogen from water, and other products, or drop-in, right? They're the same. They can go into existing vehicles and have zero emissions. Right? That means we don't have to make that investment in infrastructure, and we can divert those funds to invest in social capital, which is dreadfully needed, right? Is even more underfunded than our approach to climate change. That's number one. I feel the same about it as electric vehicles and hydrogen. Now, hydrogen has a technological debit that has to be taken into account. Namely, it does have some energy advantages over synthetic gasoline. However, 30 to 40% of those advantages go away when you have to compress it to ship, because that's a very energy intensive process. All right. And so there is a marginal energy benefit, but at a capital cost to the societies around the world. That's, just think of the existing capital stock that supports the fossil fuel industry, and think about how you have to duplicate it, not in the 100 years they did it, you have to do it in 10 to 20 years. It's not going to happen. It's not going to happen. Because of the time constraint, the conversion to using electric vehicles, which is unfortunate, but it's happening. Look, I love electric vehicles. I drive them; they're beautiful, right? And I think they have a definite role in the future, right? But at this time, meeting these threats, we have to husband our resources, but most importantly, human and capital, right? To address things that really can make a difference, as Robert said, in the short time we have available to address the threat we face. Now, I didn't always feel this way back in 2010, as Robert said. I didn't have any of these thoughts. I was a fan of electric vehicles, all this stuff. But as I've done further study and analysis and so forth and so on, I realized how little time we have. And just think about it. All that infrastructure that we built is going to be devastated if we experience the devastation of catastrophic climate change. So it's all going to go for naught. And by the way, was one of the compelling arguments that Exxon convert, because they have a lot of capital and they know, they've seen it, they've experienced it, that climate change is going to make and destroy a lot of their capital. And so they're not doing it. I mean, they're not bad people. I work there, so believe you me, they're like you and me, right? So they don't have green horns, and they're not morally deficit, but they're doing rethinking and doing it so the business survives and their capability survives, which I applaud, because we need their capability to do big projects, to install massive amounts of solar or renewable energy and materials economy infrastructure around the world.
I would love to just add to that. I had a recent conversation with a friend of mine at the Department of Energy who indicated that he expects it would take 2 to 3 years to transform the middle America, essentially, in order to create a more consistent grid to help support electrification of vehicles. It's fascinating to me how, like, I so recognize how our thoughts and our opinions about all of this evolve over time as you dig deeper into the issues and you learn things you had conceived of before. It's such a complicated web. But I have also recently had some very interesting conversations, and not to divulge too much, but with some people who have some very powerful electric vehicle technology that could, massively help improve grid capacity, and people who have technology that is, so on. It's like the tech is there, and you actually said that earlier as well. Right. It feels mind-boggling, especially, let's say those fossil fuel companies come in and say, oh, you know what, maybe this doesn't all have to exist on fossil fuels, and maybe we need to, like we should have done decades ago, is to, use all the power that we have to help, mobilize a transition that is actually going to be more equitable. And, they've spent so much money covering up things. It's
so Eric, I couldn't agree with you more. the basic notion of the following. That I'm aware of what you're talking about.
Yeah.
And I think it's an innovative possibility, right? I think it has to be costed out, right? In terms of, and by the way, something people don't talk about is, and that's something that really is very important, every technology has to be taken to its global scale, right? And see if it's scalable, right? And the minerals that are needed for batteries are not there. They don't exist.
Right.
So the limit of electric vehicles to totally convert our transportation fleet, not to mention airplanes and trains and all the stuff that's not going to happen, is very limited. And that's another reason why I say, okay, yes, do it, right? I'm not against doing it, obviously. Continue to innovate, as you're saying. But at some level, we have to have a strategic body that selects from all the technologically available solutions, the ones that can get the job in time and at a cost that's affordable to society, so it doesn't prevent them from investing in education and poverty removal and all the rest. That's what's needed. We need to find some entity, that global entity, obviously, that has the knowledge and expertise to make the right selection for the strategic path by which humanity will address the threats we face.
Ron, if I could just jump in, please. I see we've only got 5
Robert,
minutes to go.
one second. Robert, 1 second. So we usually go to about 5, but I hope folks after Robert's question, and I have a question as well. It might take us till 5:15 or so, but if folks, I don't know, Peter, do you have time for that, or?
I do.
Okay.
With this crowd, I have all day.
Thank you. Okay, Robert, go ahead.
Look, thanks so much, Peter. Really important material that you've been covered. I wanted to go back to your comment about climate sensitivity, Earth system sensitivity higher than previously estimated in view of the more rapid and extreme weather impacts that we've been seeing in recent years. And my assessment is that it means that carbon-based solutions to the warming problem are likely to be too slow to prevent dangerous tipping points. So that creates a strategic challenge, and it means to confront the public ethical debate on brightening the planet as the most tractable lever that's available to regulate the planetary temperature. And so your discussion around cooperation with the fossil fuel industry, I think, is a really key moral challenge that has to be put more front and center, a more stable cooperative path. Now, as an engineer, you would understand that when you have a critical path, if you've got something that's a complete deal breaker for the engineering, then you have to, in a logical framework, then you have to confront it as part of your theory of change, your program logic. Right. So you need a method in place to stop that deal breaker. So you can take something like Arctic methane release that could only be stopped by an albedo increase, and that the carbon-based approaches won't fix it. Thanks.
Right. So is a question. I agree with everything you said, I've indicated that the policies and decisions have to be done. I'd just like to take another crack at this issue that oil companies have not behaved morally, right? I've told you that the people in them certainly are just like you and me, and I guess somebody else here worked for Exxon, as I did. But more importantly, we could have stopped them a long time ago if we didn't want their products. They didn't hypnotize us or anything, but there was a demand to grow and improve living standards. And they were our good partner and successful partner, as I said, to enable us to talk here today. Now, as a human being, if I have a success and somebody comes up to me and says, Peter, what you've been doing for the last 30 years has been very positive, you got to stop doing it. I don't think I lay down my thing and say, yes, you're right. right? There'd be some reasonable time for them to adjust, to rethink and do it. And what I'm telling you, the good news is they're doing that. And they've all decided they have to change. Every one of the oil companies and the petrochemical industry generally has now decided they have to change. They're no longer fighting the climate change thing. They're embracing it. They're seeing it as a new economic opportunity, as I indicated, by Exxon creating a whole third new division equal to getting oil and everything else called low carbon solutions, and carbon and Corning do the same thing, and having carbon removal as a new business. So it's happening, right? I don't think it's a moral question. I think it's a question of recognizing what.
Yeah, but my focus, Peter, was on albedo, on brightening the planet as the most attractive lever.
All right, look. Let me just be clear what I feel about that. I sort of indicated. Look, I've always supported doing research to the extent you can do pilot plants type research on changing the reflectivity of the atmosphere. I think that's a great place to do research, right? And I support it 100%. However, as I said, because you can't experiment truly without doing it at the global scale, or at least the regional scale, getting political support for something like this is going to be near impossible, or it's certainly going to take a long time. And again, because of the time factor, what I'm saying is we should, as you pointed out very well, we have to identify the critical path now that have to be addressed in the short term, and the critical path when we do learning that can be addressed later, and start the efforts now to be prepared to do it when we've got in place the critical process needed. Now, I know that changing the albedo is presented to some extent as a safety valve, but it really is not, in the sense that it doesn't help address the threat of climate change. It just avoids it. So with the albedo, the CO2 will continue to build up. And when it's finally, we get there, we're going to have to remove more carbon. And so I don't see that as because of the timing, I see getting to that solution is not on the critical path because of politics, right? And international agreements needed. But at the moment, it looks like, synthetic fuels, solar, renewables, nuclear, all that stuff is widely politically accepted. Of course, as has been shown here, maybe using natural gas to help make the transition is not yet there, and certainly has to overcome all the stop the fossil fuel industry and don't invest in them efforts. But in any case, so my view is that I think I've answered that question. Ron, next.
Yeah, so let me I don't know, Bert, I would like to, piggyback on more or less on Robert's comment, and just so you know, Robert Tulip and myself and Leslie's been involved, and I don't know if we have, but anyway, we're a part of the HPAC steering circle. I think our approach, and you're very aware of this, Peter, because you were as you know, we've had many discussions of this. I think we're quite compatible. We too see an emergency timeline here, that we just don't have time. And your advocacy for let's consider using the existing infrastructure in whatever way we can to help us overcome this enormous time constraint that we have, or very short time constraint that we have. is very much, what we're concerned with, that, things are unraveling very, very quickly. And, until we can get to the other side, that's why I like the sort of, the Moses analogy, until we can get to the promised land, we have to, apply a tourniquet. And that I'm borrowing that term from Robert Tulip, actually. Some kind of tourniquet for our bleeding planet, just so it doesn't get out of control until we get our act together and create a better future for ourselves and our children.
Okay.
So that was just
I do understand.
one other thing, Peter. The second part of the question is I think one of the problems here is the reliance on what used to be called the breakdown strategy. I don't know if you had some familiarity with kind of left politics that I've been embroiled with for many years. There was a sort of Marxist contingent that said, capitalism is going to collapse, and when it collapses, people will understand that we need a better system. We need to move on to socialism. And many of us were saying, but wait a second. In that period of collapse, you might just get fascism. It doesn't, when people are stressed and overcome and things start unraveling, they don't necessarily jump to a better solution. They often, things go in reverse. So this is another problem here that I think climate scientists are I think the political analysis, and that goes to Robert Chris's point, is a little lacking here. I mean, we need a pathway that does not lead to collapse if we want to, actually develop a better future. So I'll stop there.
Well, Ron, you'll recognize that my whole talk is consistent with the last statement, right? That's why I'm giving equity such a prominence, because I don't want to have social collapse for the reasons you said, which I agree with 100%, because that will occur. But let me try to clarify. If you look at any industrial revolution, there's always a period of socialization where the public, the voters, right, accept it. The people accept it, right? Now, the one case exception to that was a hydrogen bomb, and I won't tell you how that worked out, okay? So and that's probably a lesson that's overhanging, right? And so the people are very reluctant to leave some solution to some cabal of scientists, like we're at Los Alamos, and rain their solution on them. So they're not going to do that anymore, right? They're just not going to do it. No matter how bad it is, they're not going to do what they would view as the equivalent of doing a nuclear war. So I'm stretching the metaphor, but I think you get the point. And so my only constraint about endorsing your solution is twofold. Let me straight. The great difficulty of getting social approval, and then if that has to be done in a quick period of time, diverting the focus. I don't mean a moral hazard. It's a strategic problem. Diverting the focus for a more emergency, the other emergency solution that has to be addressed. And as you all analyze, we're going to have a great difficulty doing it. That's why I say the time has come to stop thinking about all different solutions. We have them. We have that toolkit on our table to select. We have to now spend our time and focus on developing a strategic plan to address the threats we face. And when we do that, we have to take into account both technological, policy and financial realities, and social realities, and political realities. And so, and they all have to be done in an amazingly short period of time. So when you look back at history, you say, well, we can do technological mobilization once people accept there's a threat. There's really no limit to how fast we can go. I mean, I'll give you an example. We build every year, I think around 70 million new cars. Well, you only need about 50 million DAC machines to address the problem, right? So getting to that, our industrial capacity has clearly gotten to the scale that it can meet this challenge. We don't have to grow that capacity. We just have to reorient it, right? And that's why I'm favoring, because of the short time, working in partnership with a changed industrial capacity, which is happening, to help get their cooperation, and of course for them to make money at the same time by focusing their great capability on the threat we face. And I'm going to be insistent, and that's why I've stepped out a little bit and got this not-for-profit, that the technology that they implement will not be crammed down the throats of the developing world so as to enrich the developed world and further impoverish the developing world. That's the constraint. And that's somewhat of a foreign constraint for them, but it's not really something that they won't recognize already, because they all, if you look at their plans, all the growth for energy use really is in the developing world in the 21st century. I mean, a significant amount of it. So that's my response to this whole thing. And so I think we should all focus our efforts of what body, how can we, we should, and maybe something Nadia and I are going to attempt to do. What coalition of people that have thought about this problem and are committed to it can we assemble and have them commit, no matter what the solution is decided is the most strategic, based on some due diligence review, that they'll commit to support it and give up their support for their alternative as the main thing. That's what's needed. We have to first organize ourselves and talk to society with a uniform voice, rather than go through the back door and use our lobbying efforts and who knows who, but to influence legislation to get a solution that's we believe personally is the best. I've never lobbied. I don't think that's the right thing to do. I want to go in the front door. Of course, I benefit from lots of connections that are not available to others, but this is what I believe has to happen. And I don't think the IPCC is politically able to do this, or maybe, right? And maybe it can be sheltered as a separate unit under it, right? But it has to be established very quickly. And people like you and others on this call who are committed and thinking about this problem, and others, literally thousands, if not millions, around the planet who have made the same commitment that you have to find some way to come together and speak with a uniform voice. Otherwise, nothing's going to get done.
So Peter, I think we all agree on your last point there. That's why, we're forming an organization. We're trying to speak with a collective voice, and as you are as well. One point before I go to Leslie, I think we'll amplify on the point I'm about to make, who was about to amplify, and we only have, a couple minutes left here. Is that, I do disagree with your analogy of, comparing cooling to a hydrogen bomb or some kind of, major scary techno fix, which I know is the popular, in many ways the popular conception. So we've written a document that has 17 different methods, some of them very low tech, just making roofs white and cooling cities. And Leslie has one, Ye Tao has one of putting mirrors around. I mean, these are not necessarily high tech, super, not all solar aerosol injection. So, but other than that, yeah, our concession would have to continue. I just want to move it over to.
I have to tell you.
Go ahead.
Not say that what you're doing is equivalent to a hydrogen bomb.
Well, I understand.
Right, and I'm saying its perception in the culture it makes that connection.
Okay. No, I agreed. Leslie, go ahead. Sorry.
Yeah, I just wanted to be sure that you were aware of, work that people are doing on surface albedo modification, which gets around these problems of, oh my God, my one and only atmosphere, which I think may well stop, that sort of approach as ever getting adopted. And we've actually been invited to consider taking on glacial ice melt in the Himalayas, and we're building a coalition and local collaborations, and it's really pretty darned exciting to try to pivot what had started out to be intended to help preserve sea ice into what is killing people right now and having them lose their homes of all that glacial ice melt that's happening in the Himalayas. So it's become this evidently urgent problem that one can deal with in a localized way, which you can actually be invited to go ahead and try to take on these problems. So I wouldn't lump all of the reflectivity in that one atmospheric category. There are different approaches.
I couldn't agree with you more, right? And I love what you're doing because you mentioned the key word regional, right? Right. It's going to be, and all those regional efforts, efficiency, albedo modification, right? They should go full force. They should tap the energy of the people who want to help do something, right? And I love what you're doing. I mean, I think it's great, and I think
great. Thank you.
I think it's a model. It's a model for how others should think about doing their organizing their efforts. That is, form some group, right, and then try to build up and grow, and find a target that is very amenable to the idea you're doing. Do a demonstration project there, and then show, and then that will trigger with today's age many other projects following. That's desperately needed to hold down both any effort that holds down the emissions we are making, or like you're saying, the impact of the albedo on the climate crisis is greatly appreciated. What I really love what you're doing, it's in the critical area, because the polar north is where all the warming and all the devastation is going to occur. And so that's not only a regional solution, but where you conduct, which could work in other mountains and other glaciers, but that's a regional solution where it's also most important that it be implemented. So I really love that idea, and keep me informed of how you're making progress, because what Nadia and I are trying to do is to actually, in our not-for-profit, is to actually stimulate, do such demos like you're doing in the developing world, and hope that they'll be scaled and picked up by others.
Thank you so much. I put my email address in the chat kind of early on in the meeting.
Right.
We'd love to be in touch with you guys. Thanks.
Okay, great.
Thanks.
Thank you. So on that note, that's a great note. I thank you so much, Peter. This has been really, really very stimulating, interesting discussion we've had and presentation. I've actually had requests on the chat that we have to invite you again, to have a follow-up conversation on all these issues. And I know Jim Baird here was, says you can take the heat from the ocean and use it for generating hydrogen. So you have, a 2-in-1 again. But anyway, so
I would welcome that. I would welcome it.
Great. Thank you. And thank you everybody for coming, and hopefully we can do this again.